Hello, everyone. Thank you for coming. I hope you had a good lunch and now you're ready to stretch your brain muscle with me. So today I'm going to talk about building microservices APIs. So you may be wondering who I am and why you should listen to me. My name is Oli, and I'm a Scala developer like you. And recently I joined 47 Degrees company as a solutions architect. And my job as a solution architect is to go and talk to developers, to work with them on their project, to observe their pain, their suffering. And something happened to the sound. And can you hear me well still? Yeah. Okay, good. And where did I stop? So my job is to observe that, and as a solutions architect, I try to provide a solution which will help teams to solve their problem painlessly. So one of the things that 47 Degrees is specializes in building web services. So when you are building web services, you're trying to solve two problems. First one is to solve your domain problem, to understand what kind of information you want to receive and return between your server and client. But the second part is a transport layer, how you want to talk through gRPC, for example, or through REST, which serialization format you want to use. Is it protobuf or Avro, or is it JSON, maybe some other format that you build in your house. So the thing is that you want to decide that early in the process. Otherwise, you're gonna pay a lot to change that early. So the thing that we're built in 47 Degrees is the new library called Mu, which will help you to build a flexible API with two communication layers. So far, it's gRPC and REST. Then you can change different serialization formats. There is a metrics module which you can apply streaming services, security layers, and if you are going to build your microservices using protobuf that you are given, or if you have clients who are using other languages than Scala and you don't want to expose your Scala API, you can build protobuf or Avro from your Scala service. So now I'm going to talk about in details how it looks like. So the first thing that you want to provide is the message, the request and response that you're going to use between your services. So it's a case class which you tag with the annotation called message. Another thing is the service. So here you can see tagless final trait. So, and the annotation is implemented using macros. So the macros is, as you can see, if you're familiar with Java code, how you use it, it's just a method descriptor with the service name and method name and two request and response type. So it's not a magic, it's something provided at compile time. So the service for protobuf is just a one parameter type with one parameter type at annotation. So this is how you change that to Avro. It's pretty flexible, no price at all. So if you have already something that uses protobuf, in order to change that to Avro, you just change one parameter at your annotation. Also, you can implement the same logic for your own protocol. We have this library called skewmorph, which has an intermediate format, mu, and which transform different formats between each other. So inside it uses recursion scheme, which allows you to split how you traverse through your types and what do you actually want to do with them. So on the right side, you can see the mu intermediate formats, and on the left side, it can be Avro or protobuf. So here, you just need to know how you convert your types. So let's look at service implementation. Of course, you need message, request and response, and service. So the first thing that you want to do is to implement the trade to provide you a business logic, right? So it can be done like as easy as this one. Then I'm not going to go deeper in what is tagless final, but for those who are familiar, you can see that changing between synchronous or asynchronous implementation of the server side is pretty simple. You just need to provide an effect that you want to use. Then for server app, there is this bind service method generated by Mu, which allows you to add your servers to service handler registry. Then you need this gRPC config to build your servers out of that. Here we use a pure config. And then gRPC server.server provided by Mu wraps it to provide a shutdown hooks and to allow you to control the lifecycle of the server. Then all you need is to run your server. This is on the server side. If you are familiar with how it looks like with Scala PB, it's kind of the same boilerplate, except this gRPC server part, which is you need to write manually usually when you are using Scala PB. On the client side, of course, you need the channel. You want to know how to talk with your server, so host and port. Then, again, Mu will generate a mass service client, methods client for you. It will return the resource, which is very convenient and allows you to track the lifecycle of your client. So it will use it, initialize it lazily, and eventually shut it down. So, and this is how you just pass that into your implementation and use that inside. On the client app, again, here I use the helper function, which stays implicit, and just call it with my request. So on the streaming side, unfortunately, Avro does not support streaming, so this feature is supported only when you use protobuf, although gRPC supports different type of serialization, different type of serialization, so you can talk using JSON, but still through gRPC. So here, this is an example of method signatures that you need to use to say that this is going to be your RPC streaming method. So then we build a SBT plugin that allows you to generate your code from a protobuf file if you need, or generate a protobuf file or Avro file from Scala code. So overall, the important thing about Mu is that it is already used in some of our clients' code in production, and it allows you to rapidly build your API. So you can decide later on which method to expose, which service to expose. Do you want to expose that through gRPC or REST? So very soon, like this month, we're going to release the version which allows you to expose your methods via REST using open API. So you can generate open API specification. So that it's very flexible because you can change all the parameters later on, and it's very modular. If you don't need streaming services, or you want to use Monix or FS2, you can use one of them and do not bring all the dependencies to your build. Also, it's very extensible, as I said. You can implement that for your own protocol. And right now, in a roadmap of the project, there are two main things. It's Mu Kafka and Mu Cassandra. So not only gRPC and REST, but also other things will be supported. And it's open source. So as always, we're welcoming new contributors. If you want some features to be delivered faster, then please go ahead and reach us. We're encouraging all the questions. Yeah, and that's it. Thank you.
All right, I think we have time for questions.
do you have to do Scala code to protobuf, or is there a way to start with a gRPC spec, say, or a protobuf spec generated by somebody, made by somebody else?
Yes.
And then
there is SBT plugin which allows you to generate this Scala code out of protobuf that you're given.
Okay.
Yeah, and it will look exactly like I showed. It will have like case classes and tagless final service with method in it. And depending on what modules you add to your dependency, it will generate whether either Monix or FS2. Shall be FS3 already.
Thank you. Did you measure performance overhead? And I have two questions. And the second one, do you have metrics, like drop wizard metrics? And if not, is it difficult to integrate them? Thanks.
So yes, as I said, so the first question was performance overhead. So there is no huge performance overhead for gRPC service itself, but there is a performance overhead for different serialization formats, because you need to go through that intermediate format. So that's the problem. But otherwise, it uses NetT inside, so no performance overhead for these. Yeah, and the second question was? Oh, metrics. So there is a module which you can add, and it adds intersector with metrics, so it's easy to apply. Just a few lines of code, like 3 lines, add interceptor, and that's it.
Yeah, you mentioned the use of recursion schemes to, I guess, fold over these ASTs you're building. I wondered if you could speak a little bit more in detail about what shapes of recursion end up being useful and how that helped you build this. So
the question was how recursion schemes are useful for transformations, right?
Yeah, and which recursion schemes in particular?
So we use the Drost library, which is part of our higher kindness organization. So me is a part of it too. The thing with recursion schemes is that you don't need to provide a specific conversion between your protocol, between one protocol to another. What you want to do is to specify how each type in your protocol corresponds to the type of this intermediate representation. So here you can see there are no like field names, or like it's not specific to a thing. So you write it once and then whenever you use your like protocol, all kinds of instances of request and response is going to be understood using recursion schemes. Does that answer your question? Pretty much. Good.
Any other questions? All right. Thanks, Oli.
Yeah.